Yes, it's not so much on the sensor part. It's more because the sensors are normally pretty reliable. It's more of the data communication and how it's communicated. So it's normally two switches essentially and two different types of controllers gathering the data. It's two different. So say, for example, we have what we call a virtual tag system. And so we can have a data collector essentially running on site, and then it goes up to the cloud. And then we can have another one that's in a different computer on site and just different communication. And when one fails, okay, we'll switch to the other and kind of go from there. So we kind of put redundancy there. That's one of the things that we just finished with our software this year was we had a power project that wanted two different areas with redundancy in each area. But then say, for example, if something went down, we could then switch over to the other area and it would still get full data, full everything. And again, one of the things that we do is we also, if communication fails, we save data locally and we can kind of be able to bring back that data that was either lost or that if for some reason both of those systems failed, it would still save it locally. And then when it's brought back up, we can get data back up to where everybody can use it and everybody can see it. So that's where kind of the redundancy part starts to come in and click a lot. So yeah, there's a lot of different areas that you can be redundant in. Normally it's not necessarily the sensors, but it's more of from the controller to the server that is grabbing the data through OPC or Modbus or whatever communication that they're using through, and then up to our cloud server or up to, kind of the main area or the business level of the network. And then, other people can grab data from that. So it kind of helps with having redundant data and also never failing to get a lot of data. That's one of the joys of kind of now where we moved to is when I first started out, it was most of those of like, well, we don't have enough field data in order to make decisions or do stuff. And now it's kind of moved to, well, shit, we have too much data. We don't know what to do with all this data and how do we make decisions on it? So that's another fun thing that we've kind of moved to.
Right. That's why the machine learning role became more relevant because we have too much data and we don't know what to do with it. Now we need somebody that can interpret the data. Right.
Yeah, absolutely. And that's, again, one of the nice things about what we do for like predictive maintenance. It has a lot of the machine learning algorithms or just a lot of different aspects of, okay, this is going to happen in, say, for example, 30 days. Instead of having emergency shutdown, why don't you find a good time to stop it, take care of it now and prevent that emergency shutdown and kind of go from there. A great example was that we had a bunch of reciprocating compressors that were kind of scattered out in the middle of nowhere. And people were driving out, 2-3 hours to the compressor station to try and troubleshoot stuff. We put remote sensors out there and, well, actually just a computer to talk to the local control panel there. And then the remote computer can send data up to the cloud. And it changed their, they saw some problem where it was just like, instead of it being, we need to drive out there now and try and fix it. It's one of those of, we can wait to do that in a week or two when we can schedule somebody out there. And they went from having, normally about 18 to 20 site visits a month to normally it was just about 2 to 3 a month, which, obviously helps with manpower and saving on time and saving on effort. Is this a catastrophic thing that we need to fix now, or is it something that can wait to where we can look into it when we actually need to go out there?
Right. Yeah, I've seen those people talking about these sensors that detect vibrations on the engines.
Oh, yeah.
And they present it as a magic solution of you put that and then we're going to predict everything, which, it's not necessarily true. I think it's more of it works, right? But I think it's more of you need the full life cycle of the engine in order to be able to predict what's going to happen, right?
Yeah, absolutely.